Okay, I'm going to wait for a while for others to join. It seems like we still have only 0 people watching this stream, so I'm gonna give it a few minutes. Okay, I think I waited long enough. We seem to have already a few watchers, so I'm going to start. So, hello everyone, my name is Jirka Moskovčák. I'm senior software engineer working in Red Hat for more than 7 years already, and today I'm going to give you an overview of the new feature of the new feature of adding iSCSI support to hosted engine. So basically, I'm going to talk about. My talk is going to be divided in 3 parts. First, I would like to tell you some details about what we changed in the code, and after that, I will show you a few pictures of how the new changes are presented to user, and at the end, I'm going to try to show you a live demo and deploy the hosted engine on iSCSI storage. So the most important change in the code was adding a new storage backend. We added support for LVM volumes, which are used for iSCSI storages, and the storage backend was rewritten to use VDSM API. The old backend was kind of handling the storage like manually, like bypassing the VDSM, which was causing a lot of problems with VDSM, and we were fighting about for the storage with VDSM, since VDSM didn't know about that storage, and it was appearing in its storage domain. So we have to fix it. So we rewrote it to use VDSM API, and now VDSM is happy, and we are happy that we don't have to fight for the storage anymore. And that fixed a lot of bugs we used to have. So now everything is great with VDSM, and actually it also make the code looks much clearer. This is the generic storage backend class used to implement the storage API in the hosted engine backend. As you can see, it's only 4 methods, or these 4 are the most important methods. Like I will show you later in the code examples. So the storage backend has, as you can see, it has connect method, which initializes the storage, creates symlink if it's necessary, and then the disconnect method, which will clean up everything when you don't need to use the storage anymore. The file name, I don't think it's important to describe it, but okay, for any files, like we use only metadata and log space in the hosted engine, it will give you the real path of the storage on the host you are like calling it. And probably most important one, the create method, will create the actual storage for your service, which in our case is the metadata or the log space file. So how to use the new backend? It's actually pretty easy. We have to backport setup script for it and the agent, as I will show later. These are the examples from the setup script. As you can see, we use the VDSM backend in the setup. It's as easy as create an instance of the backend class, and then you just call the API methods of the backend class. In this case, here is the example code how we create the log space and metadata. You just called create, and you pass the file name or the service name you would like to create. In our case, it's log space and metadata, and also the size, the required size of the actual storage for the services. And so it's as simple as calling one method to create it. Then when the storage is created, we need to connect it by calling backend connect. This, as the command says, will create necessary symlinks if it's necessary. It's not on NFS storage because the file is actually on the right place from the beginning, so we don't need any symlinks. And then the setup script also need to initialize the log space. So in this case, it needs to get the local file name of the log space file, which it gets from the backend by calling file name with the parameter of the log space file name, and it will get the whole path, the local path on the local machine. And later, and in the next step, it initializes the log space and disconnects the backend because it doesn't need it anymore. So as you can see, it's pretty simple. It was just only 4 calls to the backend, and the backend storage, the storage for the hosted engine was ready. In the agent, it's even simpler. because the agent doesn't access the storage directly. It accesses the storage for the broker, so it's even simpler. As you can see on the very top of the page, we just have the broker instance. We need to set the storage domain, which is in our case the iSCSI. It will automatically pick the right storage backend, but agent doesn't have to care about it. It will do the broker itself. And this is actually the set storage domain method right here. Uh, as you can see, it selects the correct backend at the end of the method, and then use it for the later calls. But agent doesn't know anything about it. It's all hidden from it, and agent doesn't have to care about it anymore. And on this slide, there is the example of the code where the agent actually gets the data from the broker, and that's the part where the agent gets the metadata from the broker. So as you can see from the agent code, it's only 2 calls. So first initialize the broker, and then you can read the data you need. So it's pretty simple, and I think it's pretty neat and convenient. So I guess there's nothing like special on this part, but for anyone interested in hacking the code, I thought it's good to know. So now the biggest change for the users or administrators is probably visible in the setup script. The setup script gained options to set up the iSCSI. So while deploying the hosted engine instance, you can select the iSCSI as a storage backend, and then the setup will ask you for the storage for the iSCSI credentials and IPs and the target name. And if you provide it correctly, it will create the storage for the hosted engine. Will create a virtual machine on the iSCSI, and you don't have to do anything else. The setup will take care of setting all the necessary things for the iSCSI for you. So this is the end of the of the of the presentation part of my presentation. And if you have any questions, you can ask them now, or I will move directly to live demo I have prepared for you. So I'm gonna give you a few seconds to ask questions. Okay, either I don't know how to use this chat, or no one is asking anything, so I'm going to just proceed with the live demo. So let me share hey, that's me. I'm trying to share my terminal with you. Okay. Okay, for some reason it doesn't want to allow me to share the terminal. So I will just share the whole screen with you. Okay, so I hope everyone can see my screen. I'm going to show you the deployment of the hosted engine on iSCSI. So I guess everyone is familiar with this command. Yes, I'm feeling lucky even without screen, but please, if you are going to try it, use screen because sometimes it gets disconnected. So here is the important part. As you can see now, it's asking me to select the storage I would like to use. So I'm going to select iSCSI. Now it wants to the IP of the iSCSI target, which I don't remember, of course. So I'm going to leave it the default port. I'm going to enter the login and my password for the iSCSI portal. Now it listed the correctly listed the target, which is only one available on my iSCSI target. Now I only have one LAN, which it's already pre-selected, so I'm going to just continue, and the rest is the same as it used to be in the previous version, so I'm not going to comment it. I'm just going to select the defaults. Yes, I want to configure IP tables. Yes, that's correct. I want to boot from Pixie. Okay, I just got a request to use a larger font. I will try to do it. Okay. Okay, so for all of you who didn't see it before, this is the part of setup where I was configuring the iSCSI. So I'm sorry if you didn't see it because of my small font. If I restart it, it will probably fail because it already made some environment changes that I would have to clean it up, which would take some time, and I don't want to do it during the live feed. So I'm going to just continue with the deployment. Yes, I will just select all the defaults here. You can see. Yes. Please note that this is my testing setup. So I have my VM bound to this FQDN, which I have set up in my DHCP server. Oh, yes, and yes. So now we are done with the setup. As you can see, there is the iSCSI selected and configured. And now when I press enter, it's going to create the LVM group and LVM image on the iSCSI storage device I configured. Yeah, got another question on RC. I'm pretty sure it's going to do when I confirm it. Yeah. Yeah, I get it. Yeah, you're right. Yeah, actually now it starts to do changes to the environment. Okay, so as you can see in the log, the setup started VDSM, which then creates the volume group, LVM volume group on the iSCSI. Then it creates the storage domain and storage pool. It will create, in a while, it will create the storage for the virtual machine, which will hold the hosted engine. And this takes a while. So please be patient. And hopefully, if everything goes okay, we'll get to the point where it will ask us to install the virtual machine, to install the Ovirt engine into the virtual machine, which should happen in a few seconds. Okay, so as you can see, it created the sunlock log space, also created the VM image. Now it's trying to start monitoring the domain, and in a few seconds, it should ask us to install the virtual machine, the Ovirt engine into the virtual machine. Yeah, there we go. The setup stage is complete. Now it's creating the VM and starting up. Okay, the VM is up and running. I used a little trick, so the VM is already prepared, and I have to just tell it that it's complete. Yes. So my VM is already pre-installed, so I had to kill it like forcibly. Now it will ask me to install the engine. I already have it installed using the pre-installed image, so I'm going to press continue because the engine is already installed. Now it checked the engine by querying its status page. It replied everything is okay. So now I can select the cluster to which I want to add the host I'm just deploying. So I'm going to go with the default one. Now it's actually bootstrapping the host itself. I can show you the process in the engine itself. Yes. Come on. Yeah. So you can see the host is being added to the engine. It's installing it. Now it's starting the VDSM, and everything seems to be okay. And now the engine is up. The host we were adding is up and running. The virtual machine with the engine itself should be also running. Yeah, it's now waiting for me to kill it again so agent can take care of it and start it as a highly available service. So I'm going to kill it again, and the setup will end successfully. And your hosted engine is running on top of iSCSI storage. So that's it. And if you have some questions, I'm going to keep it alive for a while, waiting for your questions. I try to open the chat integrated to this window, but it doesn't seem to work, or no one is asking anything. If the chat doesn't work, you can also reach me on the IRC, on OFTC network, and in the channel Ovirt. So I guess that's it. Since I don't see any questions, I'm going to finish this hangout. Thank you, everyone. I hope you learned something new and enjoyed the live demo. And if you have any questions, please don't hesitate to ping me on IRC or drop me an email. I will update the hangout with contact information, and will upload the slides there, so you can download it and use it as you will. So thank you. Bye.